Welcome back to Ames tutorial. In today's session, we are going to discuss about a relative position of two circles and number of common tangents. Let S be the circle in general form, that is x square plus y square plus 2gx plus 2fy plus c equals to 0, and s dash equals to x square plus y square plus 2g dash x plus 2f dash y plus c dash equals to 0. C1 center of first circle is minus g comma minus f, and C2 center of second circle is minus g dash comma minus f dash be the centers of two circles, and R1 radius of first circle root over g square plus f square minus c, R2 root over g dash square plus f dash square minus c dash be their radius, and C1 C2 equals to d is the distance between their centers. Then we have 5 different cases. If C1 C2 is d, distance between the centers, r is the radius of first circle, r2 is the radius of second circle, then we have different 5 cases. We will discuss in this video what are those 5 cases in details and number of common tangents. Now case 1, if C1 C2 is greater than R1 plus R2, so we can draw 4 common tangents. When C1 C2 is greater than R1 plus R2 means one circle completely lies outside the other circle. If C1 C2 is greater than R1 plus R2, one circle completely lies outside the other circle. Total we draw 4 common tangents. So number of common tangents 4. We can draw 2 transverse common tangents from internal center of similitude and 2 direct common tangents from external center, means external center of similitude. So what are the formulas of internal center of similitude and external center of similitude? Internal center of similitude is mx2 plus mx1 by m plus n, comma my2 plus my1 by m plus n, where n is to n is nothing but ratio of radius, that is r1 ratio r2. So transverse common tangent from internal center and direct common tangent from external center. Now case 2, if C1 C2 equals to R1 plus R2, C1 C2 means distance between the centers equals to sum of the radius, then we can draw 3 common tangents. If C1 C2 is R1 plus R2, two circles touch each other externally at P, at internal point. So what about formula of internal center? That is mx2 plus nx1 by m plus n, comma my2 plus my1 by m plus n, where m is to n is r1 ratio r2, and external center mx2 minus nx1 by m minus n, comma my2 minus my1 by m minus n. If C1 C2 distance between the centers equals to r1 plus r2, two circles touch each other externally, and number of common tangents 3. Now case 3, if C1 C2 lies between mod R1 minus R2 and R1 plus R2, we can draw 2 common tangents and the given circles intersect each other. Given circles intersect each other. The 2 common tangent can be drawn from external center, that is mx2 minus nx1 by m minus n, comma my2 minus ny1 by m minus n. If C1 C2 lies between mod R1 minus R2 and R1 plus R2, two circles touch each other, intersect each other, and number of common tangents 2. Case 4, if C1 C2 equals to mod R1 minus R2, one common tangent when the given two circles touch each other internally. If C1 C2 equals to mod R1 minus R2, given circles touch each other internally, so we can draw one common tangent from external center. Case 5, if C1 C2 less than mod R1 minus R2, one circle is completely lies inside the other circle, then we can draw zero common tangent. If C1 C2 distance between the center is less than R1 minus R2, mod R1 minus R2, then one circle completely lies inside the other circle and number of common tangents 0.